In the previous lesson, we learned about the MongoDB driver that enables our node application to communicate with a MongoDB server and also store and retrieve documents from the MongoDB server. We also saw that the MongoDB driver provides us with many methods that enable us to create collections within a database, add documents to the collections, and then perform various operations on the documents within a collection. Now, when the documents are stored in the database, the MongoDB driver itself imposes no structure on the documents. If we need to have specific structure for the documents and enforce that structure, then we need to make use of the Mongoose node module, which enables us to define a schema and a structure for our documents that are stored in our MongoDB database and strictly enforces the structure. Let's look at more details in this lecture and the exercises that follow this lecture. As we have already learned, MongoDB stores data in collections in a database, and these collections consist of a collection of documents. The documents themselves stored in a MongoDB database have no specific structure imposed on the document. Any document can be stored in any collection, and MongoDB relies on the developer to enforce the structure on the documents and gives the complete responsibility to the developer to make sure that documents of the correct structure are added and maintained in the various collections. Now, it is very easy to violate this. So, for example, even though you might start out with the assumption that a particular collection will have documents of a certain structure, you can easily insert documents that don't necessarily comply with that structure. If you are very particular that the structure of the documents in a collection always have a specified structure and always will have the specific set of fields, then the MongoDB itself doesn't impose that. Neither does the node MongoDB driver that we have seen in the previous lesson. This is where we will need a more formal way of imposing a structure on the documents that are stored in a collection in a MongoDB database. This is where the Mongoose node module comes to our help. The Mongoose node module imposes a standardized structure for the documents that are stored in a particular collection. And so that is why we often hear people referring to this as the Mongoose ODM. The ODM itself is interpreted by some people to mean object data model, or sometimes referred to as object document mapping, or some people refer to it as ORM, or object relational mapping. Now, when we talk about relational, that applies a lot more to relational databases. But then with SQL databases, we needed explicitly the object to relational mapping to be put in between the database and our application itself. Because within the application, we would be looking at objects, but the storage in an SQL database will be in the form of records. And so you needed explicit mapping. As we saw with the NoSQL database, this was not explicitly required. But if you need to impose structure on your documents that are stored in a collection, then the use of Mongoose to impose this structure is very, very useful. The way Mongoose goes around imposing structure on the documents is through the use of schema. Schema defines the structure of the documents. Let's talk about that in a bit more detail. So what exactly is Mongoose schema and what does it bring to the table? Mongoose schema it implies a structure on the data that is stored in a document in your database. So it defines all the fields of your document and also specifies the types of the fields, and also provides with additional features that can enable validation on these fields. So for example, the various schema types that are supported in Mongoose include string, number, date, buffer, boolean, mixed, object ID, and array. In particular, we will look at string number and date and boolean in the exercise that follows. We will look at some of the other ones in later exercises. In particular, notice the use of the array schema type. So an array schema type would allow you to create an array of subdocuments inside a document. I'll talk about that in a short while. Once you define a schema, then the schema is then used in Mongoose to create a model function, and that is what enables you to define the structure for your documents in the database. Schemas themselves can have nesting, so which means that you can have subdocuments that are enclosed inside a document. The subdocuments typically are accommodated either through specifying an additional schema and then defining one of the fields of the schema to be of the type of the other schema, or you can even go with an array of another schema type within a second schema that you define. Let's look at an example to clarify some of these in more detail. This example will be from the exercise that you will do right after this lecture. Before I can talk about schemas and models in Mongoose, let's understand why we would need that. If you had taken the previous Angular or the Ionic or the native script course, you have seen that we represent various data that we use in our applications in the form of JSON strings. So in our application, we define a collection called as dishes. And in a dish collection, each dish will contain a certain set of properties defined in the form of JSON string, as you see in this example here. So the dishes is an array of dish type, and each dish itself will contain a name, an image, a category, a label, and so on. And also inside the dish document itself, you would have comments which are stored as an array of, again, JSON documents which contain specific fields there. So each comment, for example, contains a rating, comment, author, and a date field, as you see in this example here. So you see that there is a clear structure to each document that defines a dish that is stored in our database. And multiple dishes, obviously, will be stored in the form of a collection in our database and could be grouped together and sent over as an array of dishes to our client application to be made use of. Now that we have understood how this is defined, now how does this relate to the Mongoose schema and the model that we define in Mongoose? Now note the structure of a typical dish document here. So this could be easily mapped into a MongoDB document in a collection, perhaps named the dishes collection. And then, so we see that there is a clear structure to the document itself. Now, how do we mirror this in a schema in our Mongoose application? As you will learn in the exercise, we would see that we would define schemas in Mongoose. So the schema is defined as a Mongoose schema here. As an example, a comment schema is shown here. The comment schema, as you can see, contains three different fields: the rating, comment, and the author field, and also timestamps here. The timestamps allow you to have two different fields in the document: the created at field and the updated at field, both of which are timestamps stored in the form of an ISO date string in the document. Now, the rating itself would be an integer value. So in Mongoose terminology, it would be stored as a number. The type would be a number. And you can even specify the minimum and maximum value. And you can also specify that this particular field is required. So which means that every document of the comment type should contain a rating field. Similarly, you can also define a comment field which is of the type string. So obviously a comment is nothing but a string which contains some information, and this can also be defined as a required field, meaning that every document should contain a comment, and also an author field which is also of the type string. So you see that by defining this schema in this format, as we learned in the discussion a little bit earlier, schema is defined by using the various types that we have in our Mongoose application. So the schema, again, you see three different fields here: rating, comment, and author here, and each of which has a specific type given, and then whether this is required or not. So thereby you are imposing a strict structure on the comment documents that you're going to be storing in your application. Now that we have defined a comment schema, we can then, as you noticed from the example of the kind of data that we require in our application, we have a dish document itself. The dish document contains various fields. Here in the exercise, we will first introduce just two fields into the dish document, the name and the description. And in the next lesson, we will introduce the remaining fields for the dish schema. Now, so the name, as in this case, is of the type string. We can also specify that this is a required field, meaning that every document should contain the name field. We can also specify that the name field is unique, meaning that no two documents can have exactly the same name value in the document. So that ensures that each document will have a unique name field in it. And a description field, which is again of the type string, but also specified as required. Now, as we saw in the example, a dish document contains multiple comments enclosed inside the document. Now, in Mongoose, this is supported through the use of subdocuments. So if you define a schema earlier, so for example, we have already defined a comment schema here. You can also define a field into another schema that you define, and then specify that that field will be of the type of the previous schema that you have defined. So in this case, the comments field, I am defining it as an array. So you see the use of an array type in your schema that you're defining here, and an array of the comment schema type. So this is an array of comments that will be included in each dish document. So thereby you can have more than one comment enclosed in more than one comment subdocument enclosed inside a dish document. So defining the structure like this enables us to support the corresponding JSON string structure that we have defined for a dish document, or that we have seen in the example earlier. Now, once we define the schema, to make use of this in our application, we need to create a model from that schema that we have just defined. So within our application, we would define a Mongoose model and specify that the model is of the type this schema, dish schema in this example. Not only that, you will also give a name to the model here. So when you give a name to the model here, we are specifying the name as dish. Now, when you use this dish model in our Node application where we are making use of Mongoose, then this will be transformed and mapped into a collection in my MongoDB database. The collection itself will be named as dishes. So Mongoose automatically knows that when you specify a name here, it will automatically construct the plural of that name and then give the collection the name which is the plural of the model name that you specify in this example here. So when I say dish here, then Mongoose automatically will map this into the dishes collection in the MongoDB database. How does it know how to convert this singular name to a plural? Mongoose automatically has a built-in mechanism that enables it to construct the plurals of standard English words. So if you say dish, it'll construct dishes. If you say leader, it'll construct the plural of it as leaders, and so on. So this is already built into the Mongoose node module. So that is why when I specify this as a dish model type, then Mongoose will construct the dishes collection in my MongoDB database, and then that dishes collection will store the various documents of the dish type in there. And once we have created that, typically when we declare models in our application, we would store them in a subfolder named models. Just for convenience, you don't need to do that, but just to organize your application, we would normally store that in a folder named models. And then this the schema and the model would be defined in a file like this, as you see in the example here. It is called dishes.js, and then this would be exported because this is a node module. This will be exported from this file so that it can be included into the node application where we are going to make use of this schema and the model that we have just defined here. With this quick understanding of schema and model and its use in defining the structure for a document that we store in a MongoDB, let's go back and understand a little more about what Mongoose provides for us. In addition, Mongoose enables us to establish the connection with the MongoDB server. And Mongoose internally makes use of the MongoDB driver that we had used in the previous exercise. So Mongoose depends upon the MongoDB driver, which means that from your Mongoose-based node application, you can use all the methods that are already available from the MongoDB driver also if you choose to. But Mongoose itself has its own collection of methods that we can make use of to interact with the MongoDB database, as we will see in the exercise that follows. Let me briefly show you how we would establish a connection to the database, and you will do this in the exercise that follows. So just like we declared the URL in case of the MongoDB node application in the earlier lesson, we will still declare the URL for our application, and then we will use the Mongoose connect method and supply the URL for the Mongoose connect method, and this will establish the connection to the database. With this quick understanding of Mongoose and what role Mongoose plays in supporting structured insertion, storage, and retrieval of documents from our MongoDB, let's move on to the exercise where we will get some hands-on experience using the Mongoose module.